Okay, right. Good afternoon, everybody. My name's Simon Smith. I'm a chair of the CFCI and I'm hosting our webinar today. And our webinar today is being hosted by, or run by Gilbert Ash, I should say. It's one of our virtual construction site visits, but with an explanation of the design, the key design issues from the architect and the engineers as well. As with all CFCI webinars, we're hoping to have a bit of time at the end of the talk for a Q&A session. So please, if you do have any questions for our speakers today, could you raise them in either the chat bar or the Q&A bar, and then I'll put your questions to our speakers at the end of the talk. I think that's probably about all the notices I need to give today, apart from we will be recording this and hopefully putting it up on the website next week when we get some time. But apart from that, if I do a very brief introduction. So today we're very lucky to have Gilbert Ash and the design team from Emmanuel College, New Southcourt, present a virtual construction tour. So Gilbert Ash are running the show, but they have allowed to be very kind to let the designers say a few words as well. So we're going to hear today from the architect Stanton Williams, the MEP Skelly and Cooch, and the civil and structural engineers Smith and Warwick. Of course, there are other people involved in the whole process of designing and constructing a building, and you can see a few names there, but I'm sure Emmett will mention a few names in his introduction. So why don't I hand over straight away then to Emmett, who's going to give us a brief introduction to the project, and then hand over for a design chat, and then finishing off with some lovely construction shots. Emmett, over to you.
Okay, thanks, Simon. Just first of all, I'd like to thank Simon for asking Gilbert Ash to take part in this virtual site tour. It's our second one we've now done, and it's a good way to get our message across to the broader audience. We're very pleased with the progress we've made in Emmanuel College, which commenced in November last year. And we are delighted to share our design development to date and the progress images we have on site. Today, we'll be joined by Gavin Henderson from Stanton Williams, who's the lead architect on the project, Mark Skelly from Skelly and Cooch, who's the MEP consultant, and Mike White from Smith and Warwick, who is the civils and structural engineers. Following their design team presentation, Gilbert Ash will focus on the overview of the project and focusing on works that's being completed or progressing on site. This will all be led by Joanne Graham, our design manager, Robert Craig, our MEP coordinator, and myself. So I'd like to hand over to Gavin now, who will take us through the architectural presentation.
Can everyone see that slide? Great.
Yep, that's good.
Okay. Thank you, Emmett. So I'm Gavin Henderson from Stanton Williams, the architects. And what I'm going to talk about this afternoon is really to try and put some context to the other contributions today by outlining the scope and approach to the design of the scheme. And it's important to say that for Emmanuel College, this is a very major project. It's the largest transformation of the college for over 100 years. And it's also a very complex project. It's almost three different projects all in one, incorporating new buildings, adaptations to existing buildings, and a listed structure. So it's got a bit of pretty much everything and also a major basement excavation. So I'm going to try and put all that into context as briefly as I can. I'm sure you're all aware of Emmanuel and where it sits within central Cambridge. You may not all be aware that the college actually occupies nearly the entire urban block, including the houses along Park Terrace. And this project has really been enabled by the purchase of Furnace Lodge, which is a listed 19th century villa on Park Terrace, and the adjacent car park, which is behind number 1 Regent Street. And the actual development site incorporates those areas, but also stitches right back into the existing college buildings. So just to orientate you, because I think I'll be referring to these areas of the project as we go forward, it extends into South Court, which is this group of two linear buildings here, and actually opens out into Chapman's Gardens, which is back into the existing core of the college. And as you can probably see from this side, it's an area which is, before the works, was primarily surface car parking. So you can see that here on the top left, the surface car park behind 1 Regent Street. And on the right, this is South Court as it was before the works commenced. So a huge opportunity here really to enhance the environment of this part of the college, but also fill in that gap in the streetscape along Park Terrace. And that itself is an interesting and challenging issue. It's partly about the views out onto Parker's Piece, which you see here on the right, but in fact, the building very much addresses what is the rear end of the University Arms Hotel. So it's quite a gritty, constrained urban situation at that point, with the bus route running past. So that's where we are in terms of the site. In terms of the scope of what we're doing, as I said, it's a scheme very much of a number of discrete but interlinked parts. So in South Court, picked out in blue, we're creating a major new landscape space and a new social hub for the college. This is, in many ways, could be seen as the most important space of the whole scheme. It's the kind of environment that isn't provided by traditional college buildings. It's an informal, social and learning and study environment, a kind of cafe type environment, which is shared by all college members. The area in green over the surface car parking is the location for the new residential accommodation we're providing. And that's essentially 50 new student rooms, which goes a long way to providing or fulfilling the college's ambition of having all undergraduate accommodation on site. Below that, we have 2 levels of basement car parking. There is a substantial net reduction of car parking on site, but this is to take the remaining college car parking and put it out of sight so that we can enhance the landscape around the new buildings. We're also working in the basement of one of the properties on St Andrews Street, which is Jana's house, repurposing that as cycle parking. And then the listed building, Furnace Lodge, which faces onto Park Terrace, is repurposed as a new student and teaching hub with associated social facilities. So there's all sorts of different things within the actual scope of the scheme. Now, in terms of how we have actually approached the kind of rather varied challenges that this brings, it's been very much about understanding the college and the community that exists within the college, and then the way that the buildings support that community. This is one of their quotes, and for us, this is very much about how buildings and spaces promote socializing and interaction, which underpins the exchange of ideas and knowledge, which is at the heart of the college community. So a lot of our initial work was talking to the college about their community and also looking at the very unique set of spaces that the college has at the moment. It's actually quite diverse. There are the more formal and informal spaces within the heart of the college, but also the much more intimate domestic spaces that have been incorporated, which you see on the right, behind Park Terrace. And I think a key observation that we made very early on in the project was that the new site, which is picked out in the dotted zone here, is at a kind of intersection between the sequence of main collegiate courts along St Andrew's Street and the sequence of domestic spaces along Park Terrace. And that suggested to us that we would add to this varied sequence of spaces by producing something at a more intermediate scale, something slightly more intimate than the larger, more traditional college courts. And that's the idea that we've really been exploring and which is integrated into the design. So moving forward at the early stages, we did masses of little massing studies. And I know that Mark is going to talk a little bit about this in a minute from a more technical side in terms of sunlight and daylight and environment. That was a key part of this. But for us, it's also about getting the scale of space right, you know, what feels an appropriate scale of court or courtyard and sequence of spaces on this site. And you know, for those of you who know our work up at Northwest Cambridge, you'll know we're very focused on this idea about designing the spaces first before the buildings and really understanding the character of those spaces and how they are connected to each other. And that's what this plan suggests to orientate you. This is Park Terrace down at the bottom. This is Chapman's Gardens at the top. So it was very much about the landscape being at the heart of the scheme. This is one of the landscape architect's drawings. And you'll see we're creating a major new landscape space in South Court, but a much more intimate series of courtyards and courts behind Park Terrace and Furnace Lodge. And the language of those is drawn very much in terms of planting and materials from the language of the existing spaces within the college. And here in pink, you can see picked out the new interventions in terms of buildings, which are partly into the existing buildings of South Court and partly new structures around Furnace Lodge and Park Terrace. And it's an area of the college which at the moment is characterized very much by brick buildings, unlike the collegiate heart, which is more of the Ketton stone type character. And you'll see when I show the visualizations that that's what we're drawing on, particularly the orangey red of the earlier college structures that you can see here on the right. So it's really a kind of evolution of that aspect of the college's character. So this is the overall plan of the development. And what I'm going to do is to just talk through a series of images which give a feeling of what we're doing here, starting from Chapman's Gardens at the top here, looking at the new social hub, which replaces what was originally the location of the college bar in South Court, the new garden in South Court, the development around Furnace Lodge, and then the new college court itself. So this is Chapman's Gardens as it was before, when we first saw it, before we started work. And what we're doing is we're taking out that central section of the building to allow much more unobstructed views through into the new areas of the college that we're creating beyond. So this new pavilion, which is entirely timber glulam structure, column-free space, so it's a sort of wide-span timber structure, allows a great deal of transparency between Chapman's Gardens and South Court. And this is the social hub, which provides this new kind of environment for the college. And then if we look at that from the other side, this is South Court as it was, with that original bar building in the center. And again, that is being removed. This is the new social hub spilling out onto South Court, where we're also raising the level of the outside ground level so it's flush with the interior, greatly improving accessibility between the different buildings. So this is a new court space with a pool in the center and a series of pleached plane trees, very much an extension of that informal learning environment within the social hub. And this is the main group of new buildings. This is Park Terrace here. In white, this is Furnace Lodge. And the yellow buildings are what we characterize as muse-type buildings. They're new buildings that pick up on a kind of informal vernacular that exists behind the Park Terrace housing. And then the orangey buildings are slightly more formal buildings which have frontages onto Park Terrace and back into the college. And everything is about 2 to 3 stories, working with the scale of the college buildings, and very importantly, mediating really between Furnace Lodge, which is quite a small structure, and the much larger neighbours on Regent Street, and obviously the much larger neighbour of the University Arms Hotel. So you can see the sort of scale change here with the existing college bar, which is in part of Furnace Lodge on the right, the new buildings of the residential court on the left, and they sit on top of these 2 stories of car park. And the intermediate floor there has been designed so it can be removed, and we can repurpose the car park for other uses in the future as dependence on car use becomes less. What we already do have in those lower levels is a large new event space for the college, which is what you see here. So this is a double height space with a large roof light connecting to the courtyard above, and a staircase that links through into a new college bar. So again, this is a double height space, but now inserted within what was the service wing of Furnace Lodge. So a lot of this is about the kind of social facilities that enhance college life and promote interaction. This is a view of the courtyard that's above that event space. So you can see the roof light in the ground there, and the building on the right, which is an existing building, is the new location of the college bar. If we look more at the residential buildings, these are 3 stories, taking on that brick language, but with a slightly more formal facades. But what we're really trying to do is to get glimpses between spaces, places that create a degree of intimacy, and views through into the new residential courtyard. It's a characteristic of Emmanuel that you're often getting these almost unexpected glimpses between spaces at their corners, and that's something that we have built on within the design of this scheme. So that's looking back up into the main residential area of the scheme. And then back on Park Terrace, the building mediates this scale between Furnace Lodge, which is on the right, and needs to have enough of a presence to be able to tackle the very large mass of the hotel that's on the left. And what we're also doing here is creating a new informal small entrance back into the college. So those routes that we were looking for connect back to the streetscape at this point between Furnace Lodge and the new building. So I hope that gives an overall picture of the development. I'm going to hand over the reins now, I think, to Mark, who can explain some of the more technical sides and environmental sides of what we're doing and the very important sustainability drivers.
Thank you very much, Gavin. Hi, everyone. Good afternoon. I'm just going to very quickly talk you through the environmental aspects of the project. As Gavin said, there was quite a lot of, well, there was a big drive from the college for this to be about bringing the community of the college together, as well as providing more student accommodation. And the external spaces, as well as the quality of the internal spaces, excuse me, was particularly important in this project. And there were a number of options looked at, which Gavin showed you, just some of the examples. And our job was really to inform the physics behind those options, which options provided the best sunlight, daylight for planting, for daylight for spaces, etc., etc. So this is just a summary of a few of the studies that we did. In the end, we ended up with a sort of amalgamation of a number of these studies, which took the best parts of each aspect. There we go. So the sustainability strategy and the carbon reduction strategy is summarized by this slide. I'm not going to go through everything in detail, but essentially it's a fabric first approach. We're looking at the envelope and trying to reduce the energy used for heating, cooling, etc. And then we're trying to maximize passive design through daylight, maximizing daylight, solar heat gains, etc. And as Gavin said, that extends to the basement areas where we're looking to adapt those spaces in the future. So we've got light wells which provide ventilation to the car park, but also provide light to those subterranean areas. We're incorporating rainwater harvesting as well as solar PVs. And probably the most unusual aspect of this scheme is the ground source heat pumps, which we're just about to talk about. So the ground source heat pump strategy we've adopted on this project is actually an open loop strategy, which is unusual for Cambridge. I know there's quite a lot of history of people trying this in Cambridge, but this was driven very much by the college's master plan, and they wanted this, they saw this as a separate project, centralized project, which would lead to being expanded to other parts of the college. And it's something that we have quite a lot of experience at Skelly and Couch of working on open loop ground source heat pump systems, and the college were keen to explore this option. So this originally formed a separate project, but then got incorporated into the project. And some of you may be aware that we have drilled one of the boreholes and have tested that borehole, and that's showing a maximum yield of about 9 litres a second, so which is quite a good yield. We're going down to the lower Greenland sand strata, which is quite a thin strata, so it's always slightly risky when you're going into a strata of such a thin strata. So yeah, there's always been a certain amount of managing expectations from the client, and there's also a potential risk of quite dirty water at that level. So we've worked with a hydrologist very closely. We've designed the filter pack on the actual borehole itself to deal with the quality, the expected quality of water, and we've looked at the implications of the system on any neighbouring hydrogeology. So this just summarises the loads. The development itself is very heating dominated. There's not a lot of cooling load. We do have a bit of cooling load. So it's a fairly one-way street potentially in terms of putting heat, taking heat out of the ground and not putting a huge amount back in. But the plan is to expand that. So this potentially, if it's not expanded, could reduce the sustainability of the borehole. But we've come up with a number of solutions to actually extend the life of these boreholes to over 100 years, working quite closely with the hydrogeologists. And as a result, we are implementing a few things like making the system reversible, which helps with any backwashing of the filter pack in the boreholes. So this is the last slide, which basically just shows in plan the location of the boreholes. To the south, we can see the borehole that has been drilled and is the abstraction borehole, predominantly in the winter months. And then in this summer, we will be drilling the reinjection borehole, which is to the north in the paddock area. We have also looked in the future at a possible bypass into the conduit. This isn't something we're proposing currently, and obviously would be subject to consultation with the council and Hobson's Conduit Trust, etc. However, this would potentially extend the capacity from the 6 litres a second reinjection to 9 litres a second. So in the long term, as we develop the scheme across the sites and across all the buildings in the campus, we could look at that option as in terms of increasing capacity for the college. So I'm now going to hand over to Mike, who's going to talk you through the structural aspects.
Good afternoon. Can you see that?
Yep, that's good.
Right. Okay, so I think as Gavin said, this is a really interesting project, and then it's got a little bit of everything. But due to the sort of limited time, what I'm going to do is focus in on the basement excavation. It's got some of the bigger engineering challenges. So as you can see from this drone shot, it's quite a big excavation. It's roughly 40 meters across in both directions by about 6 meters deep. And right next to Furnace Lodge, the listed building in the bottom right corner there. And the approach with the basement was very much, how can we build this basement with the absolute minimum material needed? Obviously, climate crisis, we need to build with less stuff, as well as looking at the embodied carbon of it. So it's a sheet pile basement, and from talking to the Sheet Piling UK, one of the specialist subcontractors who we've done a lot of work with in Cambridge, talking to them before and after this project, we think this is getting pretty close to the limit of what you can do with sheet piles with the Gault clay in Cambridge. So that's good, working at the limit, nice efficient structure. But then once we've got that, one of the other big concerns of the basement design was ground heave. And so this is to do with long-term sort of pressure release of the soil. So rather than, like a lot of people have come across heave in terms of trees and seasonal movement of the ground, this is not that. This is more that once you excavate a big hole in the ground, you've taken all the dead weight of the soil out of that hole, and suddenly there's nothing restraining the ground at depth. And so the ground tries to heave upwards. And from the original ground investigation, the comment in that was that the ground heave of an excavation this deep and of this sort of footprint could be as much as 100 mil. And so typically, historically, I'm sure many people will have come across that the way of dealing with ground heave in a basement is you suspend the basement slab. So you have a solution that involves piles, pile caps, a suspended raft slab across, normally cast on top of collapsible formwork like your core deck, which is designed to create a void under the slab that allows the ground to swell underneath the slab, and the ground does its own thing and the slab sits there happily with a little bit of ground pressure to resist, but largely unaffected. And we did an initial study on that, which worked out there's going to be about 1,100 meters cubed of concrete to form that approach. So that's the raft slab, the pile caps and the piles combined. And the question was, is there a better way? Feels like there must be a better way, use less material. So what about a raft? So it'd be a flexible structure. The idea being that you allow the ground to swell underneath it and use much less material because of that. And the challenge from the engineering point of view was to prove what that movement would be and whether that was an acceptable level of movement to accommodate in the building. So we did some work and some research, and there are some factors like, as you're digging the hole, actually is the moment you put a spade in the ground starts to swell and you keep digging and the ground almost swells up to meet you. And so you're removing some of that soil as it expands. So actually about half of the 100 mil heave deflection gets removed straight away. And then on top of that, as we're going through the building, we're adding load. So you're adding dead weight, which is trying to force the ground back down, back to how it was. And so we did some analysis on when the load is applied during the construction phase, and what that might do based on the long-term sort of heave pressure as the ground tries to swell. Came up with an answer and applied that to the slab with the weight of the building, analysed it and came up with an answer of about 25 mil total vertical deflection. And actually across a 40-metre basement excavation, again, we did some work looking at how that would affect the building above, but actually it's well within kind of normal deflections that you might accommodate in a building. So it's a great answer for the project. When we did the quantities, came up with the answer on the right there. It's roughly 825 meters cubed of concrete compared to the 1,100. So it's about a 25% saving in pure material use. Not to mention you've got less logistics going on with, you're not trying to get piling rigs into site and all that stuff. So really good answer for the project. Saved a whole ton of concrete. And then as the next step, we looked at how we can make that concrete more environmentally friendly and reducing the embodied carbon of it. Obviously, it's a very carbon intensive material, but there are things you can do with cement replacement materials. I've put fly ash there on that slide, or cross that out, because fly ash is a byproduct of the coal industry. So it's actually quite hard to get these days. Now we've phased out coal, but GGBS is quite a common one now. Most concretes will have a proportion of it in. And so what we looked at for this raft slab was to quite significantly increase the proportion of GGBS in the concrete. So we've gone for a 70% GGBS mix, which compared to your 30% GGBS average sort of across the industry, I see the column on the right there, with a 70% GGBS, you save quite a lot of concrete, or quite a lot of CO2, sorry, from that concrete. And so we basically took your normal piled solution with a bit of work and analysis. You reduce that down to a simple raft, you quantify the movements, and then make that that raft as low carbon as you can. And overall, slightly hard to get an exact answer on the ECO2 because of the variations in where it comes from, but we think somewhere between 200 and 400 tons saved. So yeah, that's my fast whistle-stop tour of the basement design. Over to Emmett.
Okay, thanks, Mike. Sure. Everybody see that okay? Yeah. Good. So just to start off with our presentation, I just want to highlight some of the design team members that we're currently working with. It's not naming all of them, but it's naming the ones that we're currently working with, and naturally that will develop as the project develops. So with Faithful and Gouler, who is the cost consultant for the client, with Stanton Williams, where Gavin Henderson there gave us a presentation there now, architectural. There's Mike White, who's just finished off doing a brief on the structures and civils for Smith and Wallwork. We've got Skelly and Cooch, who is the MEP consultant, and there's Bidwells, who's the project manager for the project. So just a wee bit of an introduction of what we're looking to cover over the next 15-20 minutes is really we've got a welcome video that's been put together by our site manager, Emmanuel College. Now, I just had to apologise in advance. There's a couple of wee dropouts in sound, but they're very minor. I'm hoping that you still experience what he's put together for you to get an impression of what way you approach the site and what way you come in and what way you're graded on our sites. A wee programme summary, and then I touched on the logistics. And then we've broken the rest of the presentation into three main elements. So it's really New College Court, what we refer to as the NCC. That will be broke up into design and samples, what will be led by Joanne, MEP by Robert Craig, our M&E coordinator. Site progress images, what I will touch on and brief you on, and then there's a small video, just again to give you a wee bit of an understanding and a flavour of what we're doing on site, because you aren't actually physically able to come to site at the minute. You get to see what we're doing, so hopefully that captures a couple of things and what you'll be able to see. The Furnace Lodge and College Bar with the same format as above. And then the social hub there will have, again, Joanne talking about the design, coordination and samples. There won't be any site images there because naturally that's only progressing as we speak. It's the superstructure is only arriving at site next week. That will be followed up by a time-lapse video and also a small video of the drone, what was kindly Smith & Wallworks that allowed us to present today to yourselves. So just going straight into the video here.
Good morning. My name is Emmanuel College. I work for Gilbert Ash. I'm the site manager here at Emmanuel College in Cambridge. As you can see, I'm standing outside the site. We have gate 1, gate 2, and gate 3. This is also our fire assembly point. As you approach the site, you will see that we are members of the considered contractor scheme nationwide, and also the Cambridge version. From the signs you will see it's well signposted before you enter the site. As you enter the site, there is a daily risk board or a weekly risk board that shows all the risks appropriate at that stage of construction. You also have the first aider's name. You have all the fire plan, the traffic plan, your F10 on the site rules are all on the health and safety information board. As you enter the site, you will see the sign. All outdoors must. No exceptions. As you come into the site, you will be temperature checked. All outdoors are temperature checked. Are there any signs of COVID? You will then sign in. You will then wash your hands. Another COVID we have on our site. As you enter the site, if you turn to the left, it's clearly noted for inductions. This is our induction room, which we have a short 25-minute video presentation for everybody. Again, they will sit. We will then quiz all operators after the induction video. Was everything clear? Do they understand? When they leave the induction room, they either go up to my office or the site itself. They will collect their PPE at this area here, and then that allows them to go on the site. So once they're inducted and they've collected their PPE, they will then enter the site. It's very clearly noted when you enter that the changing rooms, the canteen, the toilets are all around this corner, as is the site itself.
So just going on to the next slide, just the point just of some dates on durations of interest really on the programme. So we commenced construction in November last year, and it's a duration of 105 weeks with an anticipated completion date of the 9th of December 2022. There was a 5-week enabling works what allowed us to clear the car park and also establish our site welfare that Michael's just shown you there on the video. Just skipping through a couple of wee points here, just because lines number 3 down to number 8 is really based on the NCC works with the basement construction, superstructure, envelope and fit out. So again, that was a duration there of pretty much 101 weeks. What was the main body of the project? You go down to line number 10, you can see the furnace lodge and coach house. It's an 88-week program, and that tails into the NCC works really. That's why that duration is so long. And just line number 11 is the social hub. Again, is just a 54-week duration, and starts in December and runs through to January next year when the students will occupy it. Going on to logistics, some of Gavin's slides already presented earlier was quite good and give you a feeling of where the site's orientated in relation to Cambridge. As you can see on the slide to the right-hand side, where my cursor is, that's Park Terrace. And we have our NCC building, what is predominantly the 3 blue blocks which you see here together. And then you have the furnace lodge with the coach house and also the extension at the back. And on its own, at the far side, there is the social hub. So one of the main things there that we had to concentrate on early stages really with the logistics was working through how we were going to manage the basement construction. So as you can see in the bottom image, we applied to the local council to close the footpath adjacent to our site and run along Park Terrace, which allowed us then to create more access to get the muck-away lorries really into the site. And as you can see there in the next video, you'll see a part on the site access there, what will demonstrate how the whole system actually from conception really at tender stage, working it through with the council, that the whole thing actually now is up and running and it seems to be working quite well. The fundamentals really for us driving that was ensuring that Park Terrace is free and open to the bus lane at all times. It's a very busy road with the bus routes. You would have a bus passing down that road every minute and a half, 2 minutes. So it was critical that we maintain traffic flow. Just on the next slide, I'm going to hand you over to Joanne, where she's going to touch on a wee bit of the design development and also the sample procedures that we've done so far for the NCC building.
Okay, thank you, Emmett. So just touching on the NCC basement a little bit, as Mike has described, obviously a very huge scale excavation had to occur, which required very early appointment of Sheet Piling UK. He also provided input before we were in contract. But once we go down, we need to very quickly start thinking about how we're going to start coming up again. So to help with that, we had our subcontractors for concrete package and the cavity drainage placed very early as well. And a huge amount of coordination started between the structural engineer, civil engineer, our MEP team and architects to resolve all the builders' works openings as we came back up, to also feed into rebar designs to keep us ahead of program, ordering the rebar and keep going that way. Whilst all that coordination was ongoing, there was also a lot of backwards and forwards with the concrete supplier. Mixed designs had to be approved by Smith and Woolwork, and as Mike said, with the sort of the GGBS content kind of raised a few questions going through that process, which was good, largely around sort of when we'd be pouring the concrete, because that can be impacted when the GGBS content is higher, be it in the winter or warmer months. We also had sampling to do, so there's some sample images there of the concrete type. So we started off with cube samples of the in situ concrete. Then we've done some sort of larger test wall samples. Board layouts have had to be approved, but also we have precast elements within the basement. So we had to obtain samples as well from the precast stair subcontractor, and it was about kind of fine tuning their samples to try and marry in with the in situ concrete samples as well. So that's been an ongoing process. I think over to Robert now for the next bit.
Thank you.
Yeah, thanks, Joanne. As I say, we're concentrating really here on the NCC, or the North College Court building. And what I've sort of picked, while the guys have all went for the lovely basement stuff, I picked the nice sexy finishing stuff here, where we have to coordinate the bathroom pods, which are manufactured off-site. So to the left, we can see the top lanes, which is the manufacturer chosen to produce the pods. We can see they come sectionalized and they're built up just down that little bottom sketch in the right-hand corner of their drawing. We can see how it's built on top of the piping and how the M&E coordination goes in there. And we can see to the right, that is the M&E package drawings, and how we've coordinated all those things. Emmett, if you just slip on to the next slide. And here we actually go down to the very detail where the pipes rise and how we hide them behind the pedestal of the basins. So you can see the fairly detailed design there, where we have the waste and the pipes coming out. That little section off the floor of the pod lifts out. We bring the pipes out, put that section back down again, and then we slip the pedestal of the sink in front. So you can see right down the bottom corner there, fairly detailed dimensions, and that brings us through to the pods. And then if you just flip on again. So in the pods within the bathrooms, obviously we've built a 3D model which we're able to sectionalize and twist and turn and make sure everything fits within the risers. So what we have here on the right is a sort of straight on view of the typical risers, where the soils, the wastes, electricals, conduits, trays, you can see the dry riser there. When we twist the model to the left hand side, we're getting a sort of isometric view. So you can see the dry riser for the firefighting within the building. So as I say, by building up these detailed models, we can find out where things clash. We work closely with the team to work out where our openings are required, what effects they are, make sure they're not on top of a column where you would have rebar coming out of the column and tying in the rest of the concrete. And you can actually see the little pink on the left, there's the ventilation, and we've got attenuation contained within the ventilation ductwork, which obviously stops the transfer noise between the pods. And that's where I finish off.
Okay. Thanks, Robert. So just to touch on some site progress images that we've taken and carried through on the presentation. So again, some of them are self-explanatory there. You can see in the top left-hand corner the SPUK sheet piling rig that we brought in. The rig was chosen naturally for the restraints we had on site whenever we were sheet piling close to the coach house and the furnace lodge existing buildings. It's mainly driven by the trenching that we had to install. So yes, that gives you a good feeling of what we were walking through there with the piler. Down the bottom left hand corner there really was the hydrophilic strip, and that's the typical detail that we followed through with the B2 basement slab. As Mike touched on earlier, there it's a 750 deep RC slab, and what we decided to do there is one of the methods for helping with the waterproofing was we introduced a Podlow concrete, waterproofing concrete. So the bottom 450 millimeters of the slab was your 70 GGBS concrete, and then it was then 300 mil of topping of the Podlow waterproof concrete. So again, that was typical details from Podlow that we had to utilize to ensure that we got warranties for the waterproofing. You can see there just on the right hand side, on the far right, you can see there just another method there of the basement was a fully welded clutch welded system. So again, part of SPUK's remit to fully clutch weld, which in turn is our first line of defense really for water ingress into the basement. And then just going into the middle picture there is probably the most up-to-date photograph we have, our image of the basement and where we currently sit. You can see there that we have completely completed the B2 slab, and we are commencing with the B1 slab, the temporary formwork there erected. You can also see there the size of the propping, the temporary props that we had to introduce for the basement, naturally in its temporary form until the permanent solution is in place. So again, that was a big exercise with Smith & Wallwork and ourselves and SPUK, working through them strategies and how we're going to form the corbels and how we're going to install and remove with such a tight site for access. Just the next video here, our next slide is just a video just on the NCC works. So just if I could pass over to Joanne, I'm just conscious, Simon, there that we've only 8 minutes left, so we'll try and wrap this up in the next 3 or 4 minutes for you.
That's okay. That's fine.
Do you want to?
No problem. Okay, so the next little bit to touch on is the glulam frame that sits within the college bar. There were some images of this in earlier presentations. So the subcontractor we appointed for this piece of work is called Constructional Timber, and they were brought to the table again quite early on in the project. 2 reasons for this, one being programme. This was an early piece of works, but also timber shortages, especially Douglas fir. So it's really, really important that we secured the order for this quite early on. The design itself for this area was relatively straightforward to resolve, and that was good from our point of view. But sort of the main discussions around the Douglas fir were the grading of the Douglas fir. Selection grade had been specified, but available in selection grade, as it is quite a knotty material and species of timber. So the highest you can go in Douglas fir is actually visual grade. So there's a lot of sampling and trying to ensure that what was going to be installed on site looked as everybody wanted it to look. So we had several samples sent to site, and there were images of the timber sent to us as soon as it landed in the factory. So that's in the top right image there. And also Smith & Woolwork and Stanton Williams both went to visit the factory at Constructional Timber. And so there's just some images there. And I know Emmett has some as installed images coming up as well.
And just a wee bit there, Robert, on the design concept for...
Yeah. As I say, as Gavin has already mentioned about the different floor heights and whatnot, the slides to the left, I think the floor should have been a bit darker, but what we have actually done is, because that floor is being lifted, we have integrated the ventilation and the heating and cooling in underneath that floor. You can see just there's those brown things behind the timber grills are the fan coil units which feed out and integrated through the timber work, where we have slots at the high level and we have return air pass at lower level. And the little pink one up at the top left hand corner is the extract air, which is again incorporated within Smith & Woolwork's sort of hit and miss brickwork. So
okay,
that's very quickly on it.
Sorry, Robert, I know I'm just unconscious.
No problem.
Yeah. Just very, very quickly then, I'll just touch on some of the elements there that we done in the college bar. You can see there in the top left that we have to introduce some CFA piles, 450 diameter there to help support the new structure and also to provide additional support to the existing load-bearing walls, but we retained. You can see in the bottom left there's some underpinning that we pushed through the walls as well there to assist with it. Going on through, there were some temporary works there involved, and actually while supporting the walls until the glue lamp was in place and fixed back. So on the next slide here, you can see in all its glory, really, that the glue lamp structure is now in. The trusses have been installed. They've been fixed back to the masonry wall with the stainless steel brackets, and so that in turn then allowed us to strip out the temporary works and put the roof on. Just what Robert was touching on there, just the hit and miss brickwork where you can see on the apex of the gable there, that we introduced hit and miss brickwork there. What was sampled through with Stanton Williams and the client, really to ensure that the brick selection and mortar all matched in with ensure the listed building consent was met and all the applications was discharged appropriately. Going through just on the social hub, Joanne, just there's a small section on that.
Yeah, no problem. So I think as Gavin mentioned earlier, the social hub is quite a special space within the scheme. It's also one of the areas that will receive sectional completion early on in the project. So for being one of the most sort of visually complicated or sensitive pieces to resolve, it's very early in the project. So again, early appointment of lots of the subcontractors, be it our glazing subcontractor, timber frame subcontractor, copper roofing, copper cladding, green roof, lots of different subcontractors coming together for quite intricate detailing. There's some images there from our curtain walling subcontractor Alifix. There's been many workshops working through and refining the design of this elevation so that it looks as intended, as per the ER intent. And again, accompanying that, quite a lot of samples as well to make sure that everybody is aware of what will be delivered. Just go on to the next one, Emmett. And again, so there's some images there from Constructional Timber, who are providing a Douglas fir glulam frame in this area as well, and some interfaces with the copper roofing, the green roofing, and just making sure that all these different elements are coordinated and we're all talking to each other, subcontractor by subcontractor.
Thanks, Joanne. And just Simon, there's just a time-lapse video. I think we'll skip out, will we? Because we've only a couple of minutes left. Yes,
I mean, you could probably run it in the background, Emmett, but it would be good to finish off, actually, because we like to try and be on time. Yeah, so that's fine. That's fine. So super. Look, it's nearly 2 o'clock, and I'm not surprised it's sort of slightly overrun in that it's such a complex and involved project. You can see from the many aspects, and well done for everybody for managing to get so much in the talk. And it's great to see a mix of design and construction issues, and Emmett, pass on our thanks to Michael, who did a wonderful introduction there. He's certainly a natural in front of the camera. But yes, you know, this knitting together of space to me sounds really interesting, and how Stanton Williams have approached that is really quite interesting, and probably deserves a talk on its own, actually. We've probably got so probably not got time for raising the questions, but I think there is certainly an action for Mark Skelly of Skelly and Cooch. There are 3 questions and probably more on the open loop system. You know, one of them suggesting that this could be the first of many open loop systems going forward, Mark. But I think there's certainly an action for Mark Skelly to make sure he issues a paper on the open loop experience in Cambridge. You know, I think especially with the 6 carbon budget that's coming out and the move towards electrification, certainly I think, Mark, you're going to be a very busy chap coming forward in the future. And likewise to Mike, you know, this idea of minimizing materials that we use is very important, and well done for looking into that and leading the charge on reducing carbon. That's very good as well. So look, it's 2 o'clock. I'm afraid I'm rather ruthless with my timekeeping, so it leaves it to me to say thank you to Emmett, Gavin, Mark, Mike, Joanne, and Robert, and Michael, of course, for your talk today. It was very exciting to see what you're doing, and we look forward to perhaps even a proper physical tour next year of the site. Who knows, when things have got back to normal. So thank you very much, everybody, and on behalf of the CFCI and all its members, thank you for your time taken today to put the talk together and to present it. And rather rudely now, I'm going to end the webinar and say goodbye to all of our speakers. Thank you very much, and see you all again soon. Goodbye.
Thank you so much. Cheers.
Thank you.
Thank you.